The system development lifecycle is the overall process of developing, implementing, and retiring information systems. Various models have been developed to guide the involved processes, and some methods work better than the others for specific types of projects. The following figure here on the slide showing the stages of the system development lifecycle model that is defined by the National Institute of Standard and Technology special publication. There are 5 phases in this model. The first phase is initiation, and second is development and acquisition. Third is implementation and assessment. Fourth is operations and maintenance, and the final phase is disposal. For the first phase, initiation, the responsible individual or group documents the purpose of the system and defines the requirements. Specifically, during the initiation phase, the organization establishes the need for a particular system and documents its purpose. It typically evaluates the information to be processed, transmitted, or stored, along with who needs access to such information and how. In addition, an organization often determines whether the object is an independent information system or a component of an already defined system. The specific tasks for the initiation phase include strategy, research, feasibility, planning, and requirements. The first task of an organization is to develop a high-level strategy or roadmap of work for outlining the details for a specific system release. The goal is to ensure that the system release is fully aligned to the master strategy and intent. Also, the organization needs to determine the opportunities and solution options that meet the requirements. The organization also needs to perform several feasibility checks. The economic feasibility refers to whether the likely benefits of a system outweigh the cost. The operational feasibility is about whether the proposed system will in fact satisfy system requirements as defined for the user's environments. The organizational feasibility is related to whether the proposed system is consistent with the organization's strategic objectives. The technical feasibility determines whether the available strategy and resources are adequate to implement the proposed system. Finally, the social feasibility indicates whether the proposed system will reduce unwanted social impacts. Another task is planning. The organization carries out activities such as detailing what will actually go into the system release, creating initial project plans, and improving budget estimates. And at last, the organization develops the requirements specification of what needs to be accounted for in the downstream design and implementation activities. The more detailed the requirements, the higher the probability that the design will align to the intended system release strategy and with end-user expectation for the release. The next phase in the system development lifecycle is development and acquisition phase. In this phase, the system is designed, purchased, programmed, developed, or otherwise constructed. There are several tasks that need to be performed by the organization. First is design. So the detailed design is performed to respond to requirements. In addition to designing the operational solutions associated with requirements, the design process also includes designing unit, module, integration, user acceptance, and production sign-off tests that will be used to verify the quality of all work performed in the downstream phases and environments. Another task here is procurement or coding. The detailed design of a system is realized and optimized with the intent that it will be handed off for a centralized and repeatable build that can be used for distribution deployment, quality assurance, and sign-off tests in downstream phases and environments. All data and technology connections are tested for a specific system moving through this system development lifecycle. The tests include not only all systems that provide data to the being tested system, but also all systems to which the being tested system provides data. The goal is to verify all appropriate data connections and data exchanges between the systems that will need to interact in the final operating environment. In addition, the organization needs to prepare documents. Generally, there are 2 types of documentation that are generated for the system. User documentation provides a complete description of the system from a user point of view, dealing how to use and operate the system. It also includes the major error messages that are likely to be encountered by the user. The system documentation contains the details of a system design, programs, coding, system flow, data dictionary, process description, and so on. And finally, user acceptance testing is targeted at system functions that end users will be able to execute while operating in the final production environment. Such testing ensures that what an end user does or sees meets the appropriate quality expectations. After the system development phase, the next phase is implementation. So implementation is a stage of a project during which theory is turned into practice. The major parts of this phase are the following. So first of all is the installation of hardware and software. The hardware and relevant software that are required for running the system must be fully operational. And second part here is conversion. So the old data need to be converted from the old system to operate in the new format of the new system. And during this process, all programs of the new system are loaded onto the user's computer. And the third major part of this phase is user training. So the main subjects of user training can include how to execute package, how to enter data, how to process data, and how to generate reports. And if the new system replaces an existing IT system or even a manual system, the organization needs to shift the work from the old system to the new one. The organizations typically choose one of the three following conversion approaches. So first of all is the direct changeover. This approach is when the old system is completely replaced by the new system. And this is a risky approach and requires comprehensive system testing and training before the changeover. And second approach here is parallel run. So the two systems are executed simultaneously for a certain period of time. And the same data are processed by both the old system and the new system. So this strategy is less risky, but more expensive. The third approach is pilot run. The new system is run with data from one or more of the previous periods, and the results are compared with old system results. This approach is less expensive than the parallel run and less risky than the direct changeover. So this strategy builds confidence and allows for error tracing without affecting operations. Operations and maintenance is the next phase, which includes regular software updates and replacement of outdated and malfunctioning hardware and software. This phase also involves monitoring and evaluation to determine whether requirements are being met and what is needed for improvement. This can also mean recommending additional training, operations, procedures, and upgrades. And the last phase is disposal. The disposal phase of the system development lifecycle refers to the process of preserving and discarding system information, hardware, and software. We already discussed the disposal of data assets in Chapter 6 and the disposal of physical assets in Chapter 7 in detail. Another system development lifecycle model is proposed by the Information Security Forum's Standard of Good Practice for Information Security. It defines the lifecycle in 10 stages. You can review them on this slide. The development and operations is an important approach in the system development lifecycle. It is a software development approach that promotes a more cohesive collaboration between development and operations. Let's watch a video introduction first.
Development and operations. One goes in this silo and the other goes in this one. At least that's how things have traditionally been done. But in a world in which software has become an integral component in any business, this fragmented approach can be costly and time-consuming. Forward-thinking companies have aligned on a better culture of innovation known as Devops. Devops is the philosophy of implementing better communication and collaboration between these two functions to deliver applications and services at high velocity. By working together, a DevOps culture can help a business by continuously integrating all of its developers' work and continuously delivering code changes for release to production. This better serves customers, giving the company a competitive edge, and it does so in a more repeatable and predictable manner. But DevOps also comes with its own challenges. Keeping on top of security when automating systems at scale is tough. Devops teams have started to shift security left, implementing controls throughout the development lifecycle instead of bolting them on at the end. And because identity and access management are an essential part of security, they also need to shift left and become integral components from product design to product operations.